Okay, so this is the key to worksheet section 1.1 and then part 1. And in this worksheet, you're asked to graph two linear equations. So y equals 2x minus 3, and then y equals negative 2/3 x plus 4. Notice that in both directions, in both problems, you are asked to plot at least 3 points and label the points. All right, so we're going to talk about what labeling means when we get to that point. All right, so this is a straightforward linear equation. You're just going to plot 3 points. Again, you can use a t-table. That's the way we're going to do this. Now, in a previous course, you also learned how to graph a linear equation using slope and y-intercept. That's going to be in another section, but for this section, I really wanted you to use a t-table. So, when using a t-table, your first column is your x-coordinate and your second column is your y-coordinate. And it's always a good idea to use 0 for x. And so we get, and you just plug in the value into x, we get y equals 2 times 0 minus 3. And then using the order of operations, you're going to multiply before you subtract. So 2 times 0 is 0. And then 0 subtract 3 is a negative 3. So I get the point 0, negative 3. Now when I plot that point, remember in plotting point, you're going to start at the origin, and the origin is where the x and the y-axis meet. That's the origin. And so if I'm going to plot a point, you start with the x-coordinate. Since x is 0, that means I'm going to stay at the origin. So I'm not going to move to the right, I'm not going to move to the left. X is 0, so I stay here. That's where x is 0. See, this is x equal 1, x equal 2, x equal 3, x equal 4, and so on. This is x equal negative 1, x equal negative 2, x equal negative 3, and so on. This is x equals 0. Now y-coordinate is negative 3. So if you notice your y-axis, this is positive 1, positive 2, positive 3, positive 4, and so on. And when you go below the x-axis on your y-axis, below the origin on your y-axis, you get your negative numbers. Negative 1, negative 2, negative 3, and so on. So I want to plot the point 0, negative 3. So you start at the origin. And since x is 0, I'm going to stay there, but y is negative 3, so I'm going to go down 3. 1, 2, 3. So there's the point 0, negative 3. Now, this says to label, so label means that you need to go in and indicate what those coordinates are. So the coordinates are for x, it's 0, and for y, it's negative 3. All right, so that's labeling. All right, now, for a linear equation, to graph a line, you just need 2 points, but you're asked to do 3 here just in case you made an error with one of the points, because all these points, when you graph them, they have to lie in the same line, so they have to be collinear. I'm using the word collinear. All right, so they have to lie in the same line. The points have to lie in the same line. Okay? All right, so they have to lie in the same line. Okay, so then we pick another point. If x is, let's say, 2, I get y equal 2 times, now remember, wherever you see the x, you plug in 2. So 2 times 2 minus 3. And so you get, remember, you order of operations, you multiply before you subtract, so 2 times 2 is 4. 4 minus 3 is 1. So I get the point 2, 1. So I'm going to plot the point 2, 1. So remember, you start at the origin. Now this time your x-coordinate is a positive 2. So you can go to the right 2. See, that's where x is positive 2. Now don't put your point there because you still have the y-coordinate to deal with. Now, since y is positive 1, I'm going to go up 1 because that's where the y-coordinate of 1 is. So I'm going to go up 1. So there's the point 2 to the right, 1 up. So there's the point 2, 1. So I'm going to label it. You're going to say 2, 1. All right. Now remember, to graph a line, you just need 2 points. But I could have made a mistake with one of these points. I could have made a mistake with the computation. So let's do one more. Now let's do a negative. So let's say x is negative 3. Negative 3. So I get y equals, now again, I could have chosen any value for x. Now notice I'm choosing integers. Don't unless you're told to, don't use decimals or fractions, because then you would have to estimate where they are in the plane. And it's always a good idea to use integers here. Okay, so, and you could have chosen any number for x, does not matter. I just chose 0 to -3. You could have chosen any number for x, plug it back into the equation, and you get your y value. You get your y coordinate. Alright, so when x is -3 this time, I get y equals 2 times x. X is a -3, subtract 3. 2 times a -3 is a -6. -6 subtract 3 is a -9. So I get the point -3, -9. So let's plot the point. So I'm going to, so x is -3, so I start at the origin, I go to the left 3, and then down 9. So -3, -9 is right here. So -3, -9. So I label the point -3, -9. All right, and then you graph your line. So remember, it's not just a matter of plotting these points. You got to label. You got to graph your line. Now, notice one more thing you need to notice about these is this. See all these points here, all these points that you're finding, and when I graph it, remember you could have chosen an infinite number of x values. So all these are solutions to this equation. So for example, when you plug in 0 for x and then y for -3, you'll notice that -3 equals a -3. That's a solution. When you plug in 2 for x, 1 for y, 2 for x, so 2 times x is 4. Remember, y is 1. So is 1 equal to 4 minus 3? The answer is yes. So they're all solutions. So when you're graphing equations, you're going to notice throughout the course, when you're graphing equations, you're actually graphing the solutions to that equation. That's what you're graphing. Or an inequality, you're graphing the solutions. So when I graph this line, I'm actually graphing the solutions to that equation. So these are all solutions. So notice there's an infinite number of solutions. All these points on that line are solutions. No other point in this plane is a solution. No other point. So for example, if just for our purposes, let's suppose we were looking at this point here, -2, 4. See, it's not on the graph. Make sure you understand why -2, 4 is not on the graph. Because when I substitute x -2 for x, you're asking yourself, okay, so you're asking yourself, is -2, 4 a solution? That's what I'm asking. All right, it's not on the graph, so it can't be. So let's see why. So I'm going to plug in where we see an x, I'm going to plug in -2. Where we see a y, plug in 4. So y, which is 4, equal, I'm going to see if that's going to be the same as that side. 2 times -2 minus 3. So 2 times -2 is a -4. A -4 subtract 3 is a -7. Notice they're not equal. So the answer is no. Okay? All right, so that's why it's not on the line. But any point on that line is a solution. All right. Number 2. Now, the way you want to do number 2, using a t-table, again, you unless you're told, you can do this using slope and y-intercept as well. But let's use a t-table. All right, so since the coefficient of x is a fraction, since the slope is a fraction, it has a denominator other than 1. You want to choose specific numbers for x. You want to choose specific integers for x. And you want to choose the integers, just like we did this. No decimals, no fractions, because then you would have to approximate where these points are in the plane. You always want to choose integers that are divisible by 3, by this denominator right here. So if that was a 5, you would choose integers divisible by 5. If that was a 6, you would choose integers divisible by 6. Okay, so as we go through this, we're going to talk about, well, what integers are divisible by 3. Okay, well, 0 is divisible by 3. So I can use 0. So I get y equals, so where we see the variable x, I'm plugging 0. So I get y equals -2/3 times 0 plus 4. And then using the order of operations, negative 2/3 times 0. You do multiplication first before you add. So that's 0. 0 plus 4 is 4. So I plot the point 0, 4. So 0, 4 is here. All right. Now, okay. Now, another number divisible by 3. So let's talk about the numbers divisible by 3. Divisible by 3. So numbers divisible by 3 are 0, 3, negative 3, 6, negative 6, 9, negative 9, 12, negative 12, and so on. So these are all numbers divisible by 3. So when you divide these numbers by 3, you get a remainder of 0. All right, so let's choose 3. So if x is 3, make it easy on yourself, and you always want to choose, you want to make sure that your points will lie in the plane that's given. All right, so if it lies outside this plane, then choose another value for x. So if x is 3, I'm going to get y equals negative 2/3 times 3 plus 4. Negative 2/3 times 3 plus 4. Now, a couple ways you could do this. You've learned in the previous course that when multiplying fractions, you can reduce first. You can reduce first. So 3 into 3 is 1. 3 into 3 is 1. And so this becomes negative 2 times 1, which is negative 2, plus 4, which is 2. So I get the 0.32. You could have also, if you wanted to, I'm going to go ahead and rewrite this over. You could have also, if you wanted to, instead of reducing first, you could have multiplied first. So in other words, this would be negative 2 times 3 is negative 6 divided by 3. So that's negative 6/3 plus 4. And then simplify. Negative 2/3 is a negative 2, and negative 2 plus 4 is 2. All right, so either way is fine. You can reduce first, or you can multiply and then reduce first, and then reduce. All right, so I plot the point 3, 2. Since x is positive 3, I go to the right 3. Since y is positive 2, I go up 2. Let's go ahead and label the points. You need to make sure you label the points. So this is 0, 4. This is 3, 2. All right, I need one more point. So let's do negative 3. So if x is negative 3, I get y equals negative 2/3 times negative 3 plus 4. Negative 2/3 times negative 3 plus 4. All right, so let's reduce first. So 3 divided by 3 is 1. 3 into negative 3 is a negative 1. Now remember, a negative times a negative is a positive. So a negative 2 times a negative 1 is a positive 2. And then 2 plus 4 is 6. So get the point negative 3, 6. So when I apply the point negative 3, 6, I go to the left negative 3. Remember, you started the origin. You go to the left negative 3 because x is negative. And then y is positive 6, so you go up 6. So here's where y is 6. So go up 6 from that negative 3. So there's the point, negative 3, 6. And then you plot your point. You graph your line. And remember, when you're graphing your line, you're graphing solutions. When you're graphing an equation or an inequality, you're graphing the solutions to that equation or inequality. So all the solutions to this equation are on this line. So there's an infinite number of solutions. There's an infinite number of points on this line. No other point in this plane is going to be a solution. Okay, so that's going to take care of the key to part 1 of section 1.1.